Hello everybody. I recently fixed this Sharp Roku TV LC-50LB371U. I learned some very interesting things about the power supply and thought I'd share my learnings with you to help you troubleshoot backlights and power supplies. So let me first show you that the TV is working. You can see the backlights are on, and I'm reading the voltage right now to the backlights right here. And we're reading 60 volts. Let's call it 60, close enough. And this set should have 66 volts on it, but I've got the backlight settings turned way down, and therefore the voltage is reduced. And by reducing the voltage, I've also reduced the current through the backlights, which will help improve their longevity. This right here is the backlight connector. That white connector connects the backlights to the power supply. And then off to the right here are two capacitors. Those capacitors are in parallel. So if you want to read the voltage off those capacitors, clip your meter onto the plus and minus of one of the capacitors, and it should read 66 volts. So you'll get a 66 volt reading there at the capacitors, and depending on where you have your backlight setting, you'll read either full voltage or a somewhat reduced voltage at pins 1 and 4 or pins 12 and 15. 1 and 15 are tied together, so it doesn't matter which one you read over here on this connector. And 3, 4, I think 12 and 13, but they're all tied together as well. So pick one of the positives, pick one of the negatives, and you'll be able to read the voltage that's being supplied to the three sets of backlight strips. The important thing I want to get through to you is if you're troubleshooting your TV and you have no backlights, you might actually be reading 0 volts on the power supply. And let me explain why, because that doesn't mean the power supply is bad. Although there are a lot of videos out there that say first thing you do is read all the voltages at the connectors, and if the voltages are not correct, then replace the power supply. In the case of the backlight LEDs, because the power supply is providing current to the LEDs, voltage is not necessarily going to be an indicator of whether the power supply is good or bad. The other lesson I learned was I thought I did not have 5 volts at pin 15 on this connector. So I thought, okay, I don't have voltage for the backlights, I don't have voltage for the main board, so this power supply must be bad. Well, I didn't have 5 volts at pin 15 because there is no 5 volt circuitry. The 5 volt circuits and components would be lying in here. Capacitors, inductors, maybe some diodes and resistors would all be in this area, and as you can see there are no components here. So there's no 5 volt being read there because this TV set doesn't require 5 volts. Back to the backlight problem. You have no backlights. You're reading 0 volts on that connector. And here's why. So to test this power supply, how do we simulate failed backlights? Well, in my case, I had 5 failed LEDs, and every one of the LEDs had failed open. Not short circuit, they had failed open circuit. And each of the 3 LED circuits in the backlight had at least one defective LED. So if that LED is open, that means that entire circuit is open. So I had 3 complete open circuits, and therefore I had no backlights at all. Making sure the TV is unplugged and off. The best way to simulate that would be to unplug the backlight connector. So now I have no backlights connected, and we're going to measure the voltage again at pins 1 and 4. And I have these little jumpers that I've created here with little connectors on the end of them. And I'm just going to connect those to pins 1 and 4, and we'll read the voltage here in just a moment. I have it all set up so I can demonstrate this for you. I have a red and black lead on the plus and minus of the LCD backlight power supply. Incidentally, the minus here is not chassis ground. So if you want to compare your readings to mine, make sure you're not using the chassis ground or some other grounding point. The chassis ground and the ground of this circuit are not at the same potential. And then Additionally, for other purposes, I've added some leads so we can look at the voltage across the power supply capacitor. As I told you, I have it dialed down a little bit to reduce the backlight intensity. The meter on the right, the red meter, is for the backlight power supply capacitors. And the meter on the left is for the actual voltage that is being delivered to the backlights. It is my belief that these two LED driver integrated circuits are responsible for determining how much current flows directly to the backlights. The next step is to plug the TV in. As I'm doing that, I'll let you watch the voltages here. Again, the right voltage is the backlight power supply, and you're going to see that come up to 66. Here we go. Sorry. It'd be helpful if I got it off the 20 volt scale. So right now the set is trying to get into standby mode. That voltage on the left is 0.04, so 41 millivolts. There's not much going on there yet. So once the red blinking light on the front of the TV stops flashing, let's just take a quick look around and see what's going on. See, it's still flashing. Once it stops flashing, that means it is in full standby mode. There we are, it's in full standby mode. I've got my remote control here. Well, since I'm not in the front, I'm just going to use the power button on the side of the control panel here. So let's watch the meters. I'm going to turn the set on from the power button over here, right here on the side. Let's see what happens to the voltage. Again, there's nothing connected to the backlight connector. So open circuit, no load. See, it jumped up to 90 some volts and settled back down. The turning on of the TV just simulated a no backlight, open backlight circuit. And this explains why, if you're measuring voltage, if you just happen to come back to the power supply and try to measure the voltage there and you're reading 0.042, if you're reading essentially 0, nothing wrong with the power supply. In fact, the power supply started up, produced the voltage it needed, sensed that there was no load, no current flowing, and then shut itself down. So while there's 66 volts available still off the power supply, there's no voltage available at the connection to the backlights. Bottom line here is this power supply is working properly, even though the voltage at the backlight connector is 0. As you saw, during startup, it actually runs up to the 90 volt range and then turns off. So the power supplies are turning on, full on, and realizing there's no current, some switch between the power supply capacitors and this connector, which again, I think is these two integrated circuits, is turning the power off and not allowing any current to flow through the backlight LEDs. And as I said earlier, the LEDs require current to illuminate. Be sure to check out my other video. I repaired the backlights, replaced all the backlights. Be sure to look at my other video. You can replace all the backlights with brand new backlight strips for under $25, somewhere in the $22 to $25 range. My other video has some tips about how to get the very delicate LCD panel off of the TV without damaging it. So thanks for watching. If you found this video informative, please give me a like, thumbs up, and subscribe to my channel.